Today I'm honored to be back in the security field after 5 years in a different field, in IoT field. And today I'll talk a little bit about how I'm merging these two things together from my past 15 years of security experience with a solution of multiple IoT products that we're developing. So just quickly on my background, I was founder of Kirion, which we did computer security training worldwide with PECB at the time, trained CISSP, ISO. So I know very much of how the whole security thing started in '98 in security. And the other part of the business was network and digital forensics. And we'll see how those things merge into the products that we're developing right now. I know that you people will have to implement security in business cases, and you will have to so add layers of security to IoT solutions. You will have to choose IoT solutions and give analysis, a security analysis of it. My experience has been designing the IoT solution with security in mind. I'll just give you a little bit of context of what I do so that then we can apply that knowledge and we'll see what's so different about IoT than the rest of our security knowledge. So water leaks are the main cause, the first cause of insurance claims in Canada. It's over 50% of the insurance claims. And in condo buildings, it is 95% of claims, and the impact is worse because of gravity. Water just falls many condos one to the other. And so that's the problem, the main problem that we are creating a solution for. So to give you the context, we have a smart water valve that's installed at the entrance of the condo, and we have smart thermostats that detect presence. There's a load of sensors in there. We also have water leaks detectors. So we install 4 to 5 equipments per condo in one whole building. So if the building is 100 condos, we have 500 devices in there, and multiply those devices by about 12 sensors each. And you get the amount of data and the amount of sensors that we manage in there. So the whole solution saves on insurance, saves on energy, and adds security. With that in mind, plan today is to talk about the challenges that we face, and what's very, like the challenges that we face are the same than other things, but then there's one big difference in IoT, and I'll tell you about that. And then we'll talk about solutions, and just a trending, a foresee of what the future will bring to us and how can we prepare for that. So what is IoT? IIoT is what I think you guys will have to secure the most here. So there's the Internet of Things, but there's the industrial Internet of Things. And that's the word that you should be on the lookout for. It's just another trendy word, a buzzword, to talk, like in the past we talked about SCADA networks. They were not connected in exactly the same way, IP and stuff, but it's the same thing. We also talk about M2M networks, machine-to-machine networks. So there's nothing new here, it's just more and more connected. And unfortunately today I will provide more questions than answers. This is my humble try at answering those questions. And we're a startup, so I can't say if we have found all the solutions yet. So why is it so difficult to secure IoT? First, it's uncharted territory. So if you look on that, I love this because we have to create the map as we go along. But we still use the same tools that we used in the rest of security, right? Just all the different principles and all the methods that we developed are still usable in the IoT world. But it's uncharted territory. There's things that are automated now that we never thought about automating before. So here's a typical architecture of IoT. And you have all the apps, the cloud, the data, and a gateway. Sometimes this is the customer, sometimes this is a partner, another company putting their equipment, and they'll provide you services. So as a matter of fact, that's what we do. We provide a gateway, we provide a secure cloud network, and we provide a service and not just the devices themselves. And then you have all those wired, wireless connectivity to devices, to sensor hubs. So sensor hubs are just hubs of like, you plug in more and more sensors in there. So basically what we have here is we've just multiplied our attack surface like crazy. If you just think about the area that you have to cover and you just do a circle around each of those, the attack surface is just getting bigger and bigger. Now, first question that you have to ask yourself when you're going for an IoT solution is which standard is going to be your standard? And unfortunately, often it will be many. And then your attack surface is, again, many times wider. So those were the physical protocols that you have to choose from. Then you have to choose a logical protocol. It can also be proprietary, right? And then you have to choose a protocol to get your data out, to get your data to the cloud. So all of these protocols are very different. All of these protocols need to be secured in very different ways, and all of these protocols have their strengths and their weaknesses. And when you combine all of that, you get a big mess. So risks versus dangers. So we're used to talk about information risk. We're used to talk about financial risk, right? But in IoT, what I feel is very different is we have to talk about dangers. Let me show you in one image. That's danger. So would you like would you like to have your pacemaker connected? I'm sure not a lot of people will raise hands, right? So we have to talk about Stuxnets because that's 2010, 7 years from now, in the past. And Stuxnet is a very important date, 2010, because it is the first time that a natural virtual attack triggered a physical impact. So the centrifugal nuclear stuff in Iran was attacked from a virus. And they destroyed some motors, some engines to do that centrifugal nuclear isotopes. And it is very interesting because for the first time, a virtual attack could have impact on the physical. So let's think about that. The thing is, all pacemakers sold today, have a form of connectivity or another to do a firmware update and stuff like that. So IoT security is tackling huge problems, namely 3 principal problems. The first one, safety. We just saw the impacts can be huge. So safety as impacting humans. We're not just talking about financial or information or brand or etc. Physical security. With IoT products, by design, you're out there. Just don't think about a security perimeter. By design, all those products are accessible because the sensors need to be deployed where the information is, so where the risks are. So by design, you have a big problem in there. And I'll talk a little bit about that, what it implies a little bit later. But all your devices are accessible, and people can just grab them and try to hack them and modify them and etc. And that's a very different risk. And then privacy. privacy is huge. We are just seeing some implications with mobile devices and all the attacks on the mobile devices. But let me tell you this. We know that Friday night, the temperature and the humidity rises in the bedroom. That's as far as the stuff that we do can impact people. We know a shitload of stuff. We just found out it was completely, we stumbled upon that we found out when your fridge is going to need to be replaced. The stuff really all over the place, and I'll jump back on that later. And the problem is that, again, nobody wants to pay for it. Both in customers and in investors. I had one single investor ask me, is the product secure? And customers, they ask about stuff, they ask about details. They don't have a general security understanding, but they do ask about some details. When you give them a little bit of opportunity there, a little bit of information, they do ask about stuff that they understand will impact their life. So I'll talk about how, for example, water is essential for life, and we are controlling water. So that's one of the areas, and I'll talk about that. So the different challenges that we have to face as a security community. The first one is it's all about business again. It's not about technology. It's all about business. And when you're going to choose a protocol, it's not going to be chosen for security reasons. It will be chosen for business reasons. It will be chosen for functionality reasons. And we'll have to make do with that. Then the BOM cost and the longevity of the product. So the BOM is the bill of material. So if you add security chips in your bill of material, it adds up a lot of cost into your devices. And just take our example. So we deploy, I said 100 condos, 500 devices. Just multiply a couple dollars extra as a cost per device. It is huge. To have all the cryptography and all the processing power to do security in there is huge. The other thing is longevity. So IoT devices, we see a lot of smart products that are ephemeral. They're just gadgets, right? They're going to be replaced in 18, 24 months, and it's just version upon version, etc. We chose to go the other route. Since we are soldered on your plumbing and screwed on your walls, we thought the product must stay alive for 10 to 15 years. And so having this business goal, then it makes everything, you just outgrow everything. We have to put bigger chips to be able to do the protocols of the future and the security of the future and keep adding features, and etc. So the costs are huge to do security right. And then there's development cost and time. If to implement security in the development, to do it at the early stages and go on. And the other thing is, if you look on, there's 6 jobs in Canada that you can have a work permit for a foreigner in under 2 weeks. In under 2 weeks, you can get a work permit in Canada super quick if you're a foreigner. And one of those is embedded developer. So actually an embedded developer is more of a, it's someone who's there are more scars than security people. So think about that. Then try to find an embedded developer that knows shit about security. That's a unicorn right there. So development cost and time is also a very big challenge that we face. In architecture, more protocol to secure, more internet connection points. Then you have possibility depending what kind of IoT you're going to deploy in which area, if you can, don't go that route, but mesh networks. Mesh networks meaning all the devices speak to each other, all the devices speak to each other before talking to the gateway. And that just involves more and more surface area of attack. And there's not a lot of tools to secure those networks. A lot of the data that goes on there is in proprietary formats, and you kind of have to develop and take that into that consideration as you develop. Tech challenges, so all the key management, you're just exploding the different types, the numbers of devices, the secure storage, a secure boot at the device, how to do firmware updates over the air, and how to have all of that in a secure fashion, because as I said, all those devices are accessible to people. So they could go in there and modify code and go into that mesh network. And of course, all of that has been counterbalanced by UX, the user experience. As we all know that if you put too much security, you'll have a problem. So it's still very important so that these products, our products are used in elderly homes. So that's one big concern. It doesn't have to be, you don't need a training to use them. Legal challenges. We're again in uncharted markets. There's a lot of legal gray zones. For example, we have contracts with the building, but there's a lot of private areas. So are we entitled to have this data or not? How do we secure it? So back into how we do the architecture, that point a couple of those things, you have to think about that and think, okay, yeah, we have a customer, that's the paying customer, but we also have people that are not paying customers and are picked up by all our sensors. The different business models is also a legal challenge, and all the data exchanges. One of the things in IoT is that there is so many devices, so many different things. So as we said, the gateway, the sensor hubs, and the sensors, that you end up working with a huge number of partners. And I'm not even talking about the cloud side, which I'm sure you had in other conferences where there's also a lot of partners. But we're dealing with huge number of APIs, of partners that we have to rely on the libraries. It's very, very difficult to keep a track of all of that. So the privacy concerns are also some acceptability challenges. And so we tackle those with very down-to-earth grounding principles. We do not have the data available to people unless there's an emergency, for example. So stuff that is part of our design. So the reality is embedded devs are harder to find a security experience, and iterative or agile development process is too fast for a thorough analysis. So we start with a prototype as a startup, and then we just grow and grow and get it out and do better revisions all the time. So it is very, very difficult to apply very strict security enforcement all the way. And so solutions that we apply, first is go back to basics. So going back to basics means simplifying the things, going back to what's important, going back to, well, we are impacting the physical world. So let's stop thinking about IT just for a second and just think about the physical world first. And to make it understandable for everyone. So I don't know if there's a lot of people here that are fans of Isaac Asimov's work, but my simple rules to get all of our security knowledge into very actionable steps, right? A robot may not harm a human. So the first thing that I look for when we design solutions is how do we implement fail-safes. So the first thing is our water valve. If there is, for example, if there's a problem, a technical problem, there's a network problem, if there's an energy problem, the hydropower is out, well, the valve must stay open. If you come from Quebec, you've lived through the ice storm crisis 20 years ago, and people did not have energy for weeks, but they had water. They could stay home. If you don't have water, then you got a whole different crisis to manage if you don't have running water in the building. So that's just one example of how we think at every step in our thinking. There's fail-safes. The other thing is the fail-safes are implemented as much as possible on the lowest layer, the hardware layer in itself. So our hardware will not, as you plug the hardware, it will not, for example, the smart thermostat, it will not allow, by hardware design, it will not allow the system to go below 7 degrees Celsius heating. Because if you get under that, then you get problems of pipes freezing, pipes bursting, and all the stuff. So people can try to hack the thing as much as they want, but physically in the hardware, it's locked in. So the stuff like that we do, that we implement in our design. Second, a robot must obey the orders given it by a human. So always have a local override. This is how we design. So every time that there is something that our artificial intelligence reacts to, it can be overridden by the human. So basically what we say is that every time the human touches our devices, we have something to learn. It was not intended, we have something to learn. And then we analyze the data and try to understand what happened. Why didn't the artificial intelligence not think about that outcome correctly? And then the third one, a robot must protect its own existence, meaning fail secure. So everything must be fail secure. Also in the hardware layer, and then another example, there is a fire, a kind of a fire trigger. So if there's too much heat into the devices, then the device shuts off by itself, or it will even destroy itself at another layer if it's too hot, if it's too warm, and it could cause a fire, for example. So the device is always trying to fail into secure mode. Another thing is the fail secure. So we have rechargeable batteries in the system so that even though there is different, as I said, the internet goes out, the electricity goes out, we can fail into a secure state that the system still works under minimal conditions and that we still watch out for the important things so that we keep the building and secure. And if you're familiar with Asimov Law 0, which here is more like my law number 4, but a robot may not harm humanity, is be sure it can't be used as an attack vector for others, is how I implement it. So basically, all of these systems, they could be hacked. And you want to prevent the other ones from being harmed, and you want to prevent other organizations, other systems to be harmed from that one. We chose, since we're not a consumer technology, we're not selling to consumer, we chose to not be compatible with a lot of systems. So we chose to implement a standard protocol, but have our own proprietary thing over it and not use IP on our last layer. So it gives us more, gives us more difficulty to act the different systems, as our last layer is not IP compatible, and then you cannot just jump around on our mesh network with IP. The future, what the future holds for us. New protocols still. There's a lot of new protocols that are coming out. New security protocols, which is a good thing. New communication protocols are coming also. Communication protocols for lower battery usage. Lower battery usage means we don't do as much security. We don't re-authenticate all the time, and et cetera, and et cetera. So there's still a lot of risks that are being created out there. There will be new architectures with that mesh network. There will be new architectures with all the different wearables that are going to be into the consumer tech. But I'm more concerned about the IIoT, as I said, the industrial IoT. Blockchain technology will come to the IoT. So if you're familiar with blockchain technology, all that ledger, that universal ledger will come to the IoT world. It's just a matter of time and a matter of, does it make business sense? But it will be there to help us secure things in a sense. In the other way, though, we will have a totally decentralized platform, and that will bring many, many challenges to secure. And AI is more and more used. So with the data that we generate, as I said, just 500 sensors in one building, with the data that we generate, there's a lot of AI that's done on that data, and we're just scratching the surface of what we can predict and what can be done. So quickly wrapping up, IoT and AI future attacks, because AI is using the IoT data, meaning you can mess with the AI if you mess with the data. So, and that's where my past as network and digital forensic passion is very interesting, because we see all that data going out. And one of the things that we're worried about is we have to build into the system at every design time checks and balances. Because yes, you can go and screw with the network, but what if you insert corrupt data? How's the system going to react? If you insert bad data, how is the AI going to react? So it's not only the network and the devices, but it's also the security in the data that is created by those devices. That data is sent to the cloud. For example, we use separated database for billing and for all the IoT data, so that we can't have an easy link from name to data. So there's all that side of things that you still have to apply proper security guidelines. But there is also the fact that once you put data in there, that data may be a risk. So security is a choice, again, in IoT, and we have to choose. We've often been told that we have to choose between security, functionality, and ease of use, and we have to choose the mold point that's okay for us, that's okay for this business department, for example, or this business risk. But what I found out in my the last 3 years building security IoT products is that it's not a triangle, it's actually a tetrahedron. And that's the last one that you have to optimize for. And that's one big thing that we don't have. Because as IoT goes in, the speed of change just goes quicker and quicker, and the amount of data goes bigger and bigger. And so that's the challenge that's ahead of us, is trying to simplify how we implement security. We have those ISO systems, and I believe in them. But how can we make them so that they are agile and quickly, and that we have just simple rules, as I said, so that people every day think about how they design the product. If you're a security consultant, this will be your world in just from right now to the next 5 years. It'll be daily. In 5 years, it's going to be daily tasks. The industrial IoT is coming, and it's coming fast. Thank you. Any questions? Yes. How do you handle massive rollouts with firmware updates and things like that? So there is a partner for that, actually. So as I said, there's a lot of APIs, and there is a partner for that, and they do that part of the stack. We haven't had to do massive rollouts yet. We haven't had to do massive rollouts yet. We did our first install. So we installed 3 buildings in November, and we just finished the pilot. And the customer was, well, actually, the pilot was supposed to last 24 months, and the customer signed for 16 buildings, so we're very happy. But we'll have to roll that out and think about all those details in that one. For the pilot, it was not an issue. We did push updates into all the gateways and a lot of systems in the cloud and the gateways, but we didn't have to push updates into the devices themselves yet. Work in progress. Any other questions? Yes.
Just want to specifically ask, basically, depends on the march on the beacon technology.
Yeah. So any specific questions on beacon technology, how to secure it, or what?
Yeah, exactly. Like it's a Bluetooth on your devices. Like what kind of like threats pose? That's like, for example, an IoT connected. That it is a possibility that it can bring the demand of services in sense of the through the connectivity.
So. I will assume that you're using beacon technology for commercial areas, or yeah, for retail. So retail, right? To get all the people that are passing by and trying. So it's still, to my knowledge, and I haven't worked a lot with Bluetooth. We just don't use Bluetooth in our system, but. To my knowledge, right now it is, somewhat okay. The big thing will come with 5G, because 5G will merge that feature and will actually allow the retailers to push live ads on people's phones. So as you walk by, you will be able to see a pop-up on your phone. So that's when bi-directional stuff could happen. But if you want, I have someone in my network who is an expert on Bluetooth and uses it for as actually a solution for airports and all public places. And they actually do all the marketing side. So if what's just applying old principles to the new way, to the new physical world. So if you go to your website, you have Google Analytics and all of that. Well, his system is basically Google Analytics for physical retail space. So you know exactly how much people pass time in front of this, etc., when they come back, and then you can get that information out. But right now, I know that their devices are just scanning constantly. I'm not sure if they can send something from the phone to the system right now, or if there's any possibility of an injection. But once that 5G is out, that will be a possibility. Yes, that's the state of beacon technology. Other questions? Thank you. Oh, question. Yes? So,
For example, which are the issues related to IoT that can be solved from this security problem? Can IoT issues, for example, I need to use IoT systems, devices, etc., to penetrate, to access to business application system for organization?
yeah, so this is actually an architecture issue. So to give you an example of how we address that, it's very simple. We don't really provide the product. We provide a service. So basically, the whole architecture, the whole typical architecture that you have, we are providing the whole stack. So nobody can connect to any of those layers except the cloud through the app, right? And we also send text messages and stuff like that for different types of alerts. But that's the way that we secured it on a design perspective. So like there's nobody in the building that can connect to any part of that stack. Even the link to the internet is actually a private cellular connectivity. But we changed the business model for that. Do we really have, as I said, we're a startup. We just started this selling. Do we have the answer? I can tell you that. I have probably as many questions as you have concerning that. But that's one way to look at things. So from a design perspective, how can it be completely separated? Depends what's the business requirement for that. Yes?
So do you use the public cloud at all? Do you use Amazon, or this is your cloud?
No, we have a private cloud, but I mean it is a private cloud like it's a Microsoft cloud, right? It is just a private, it's not the public cloud. It's not, what I'm saying is we're not using the Wi-Fi of the building. We're not using any connectivity. We don't have any interoperability with other people there. That's a choice, a business choice that we made because we felt that it was important to provide quality of service to the people and not just a gadget. As I said, since we're physically installed on the plumbing and screwed on the walls, our contracts are actually 10-year recurring contracts, monthly fee contracts. So that's the time frame that we have in mind when we deploy that. So the quality of service is what we aim for. Yeah. Thank you very much.